Dear student, in the previous classes, I had given you the details of the group 16 and discussed the atomic and the physical properties and some of the compound. Continue to this topic, something is left and something is deleted. But in the deleted portion that your syllabus is reduced, I will give less stress on that. So today's topic is that is ozone. This is ozone, O3. There are very little question in that. How ozone is prepared? Ozone, that is the thick layer of oxygen, is called the ozone layer, and it is found 16 kilometers above from in the atmosphere from the earth. Now this ozone is prepared by oxygen in a Siemens ozonizer by passing the electrical discharge, and this is called the sparkless discharge. What is the meaning of a sparkless discharge? Right? A silent electric discharge is called the sparkless discharge. If you will see the reaction, this is 3O2, then it will give, that is twice O3, and delta H is positive. This one. This is delta H is positive. So value is given, that is 142 kilojoule per mole. So if the heat will be more, then what will happen? Then ozone so far will decompose back to give oxygen. That's why a sparkless or silent electric discharge is given into that. Now this ozone, methods of preparation. Now this ozone is found in the form of gas, that is also found in the case of deep blue liquid, and also found in the form of that is black or violet black solid. So the characteristics of these are the physical properties of the ozone. Now this ozone will act as a oxidizing agent, and the ozone is thermodynamically less stable. This is very important question. Ozone, how ozone is thermodynamically less stable. So this is so you will see this is twice O3, and it will decompose to give 3O2. This is gas, this is gas, and decomposition, the delta H will be negative, either reaction is exothermic. When ozone decomposes, then it will give oxygen, because from oxygen, by passing the oxygen in Siemens ozonizer, the ozone can be prepared. Now this ozone can decompose, give back to the oxygen, and because decomposition, so delta H negative, the reaction will be exothermic. Now if we calculate the entropy change for that reaction, in final, this is also gas, this is also gas. So entropy change as per the concept of the class 11, S final minus S initial. So here 3, here 2, so this delta H will be, this is positive, and this entropy, this is called entropy change. You know the term entropy change, right? Now we know from class 11 we have a concept of the Gibbs-Helmholtz equation, delta G is equal to delta H minus T into delta S. What will happen? This term delta H is negative, and this delta S is positive. So this term is negative. When the temperature increases, this term will increases, and this whole delta G becomes क्या हो जाएगा? Negative and negative. That's why it is thermodynamically unstable. What we write here? This is a reaction is exothermic, delta H negative, delta S positive, whole delta G becomes more and more negative. That's why thermodynamically it is less stable. It is less stable. This is. So this is thermodynamically it is less stable. So this is the first question related with that ozone. Why ozone is thermodynamically less stable? The reason, the reaction is exothermic, so delta H will be negative, and entropy change will increases because the number of final minus initial. In final there are 3 moles and in the initial that is 2 moles. So delta S will be positive, and we have the concept delta G बराबर क्या होता है? delta H minus T into delta S. डेल्टा एच निगेटिव है, डेल्टा एस पॉजिटिव है, डेल्टा जी क्या होगा? होल एंड मोर निगेटिव होगा. इसीलिए रिएक्शन क्या है? थर्मोडायनेमिकली अनस्टेबल पाए जाते हैं. नाउ अब इसमें कहा जाता है, इसकी प्रॉपर्टीज में जब आएंगे, ये तो फिजिकल था और ये इसकी प्रॉपर्टीज थी. अब इसमें आता है कि इट विल एक्ट एज एन ऑक्सीडाइजिंग एजेंट. ये कैसे हम लोग पता करेंगे? राइट, कहता है कि ओजोन एक्ट्स एज एन ऑक्सीडाइजिंग एजेंट. O3 acts as an oxidizing agent. This is so many times asked this question. Now this O3 will decompose to give O2, and this is nascent oxygen. This nascent oxygen, NaSCENT, nascent oxygen. Because ozone on decomposition gives nascent oxygen, that's why it will act as an oxidizing agent. And one reaction given in your book, lead sulfide plus 4O3, that it will converted PbSO4 and plus O2. This is 4O2. This is 4O2. So this is called their oxidizing property, because it oxidizes lead sulfide to lead sulfate. This is the reaction, this one. So this will act as a oxidizing agent. Now another property is ozone. How ozone is estimated volumetrically? Estimation of ozone volumetrically. This is also a question. How ozone is estimated volumetrically. So that is ozone is treated with aqueous solution of potassium iodide buffered with borate buffer, pH value 9.2. So it will liberate iodine, and this iodine liberated is titrated with standard solution of sodium thiosulfate, and hence the ozone is estimated volumetrically. So the reaction in this is one. This is twice I minus plus ozone plus H2O. So this iodine will get oxidized to I2, This is O2 and plus twice OH minus minus minus. So what will, how ozone is estimated volumetrically? It is treated with aqueous solution of potassium iodide buffered with borate buffer pH 9.2 liberate iodine which is titrated with standard solution of sodium thiosulfate and ozone is estimated volumetrically. How does it mean? The iodide gives iodine and this iodine is titrated. How much amount of iodine is liberated? By this equation we can see it. And this iodine is titrated with a standard solution of thiosulfate Na2S2O3 and the sodium thiosulfate, and we are estimate the ozone volumetry value. This is another aspects of question. This question is also asked in so many times in the examination. Now come on, the resonating structure. So there are two questions given in your book: how ozone will act as the oxidizing agent and how ozone is estimated volumetrically. And the another one is resonating structure and its uses. That's it. देखिए इसमें है क्या हम लोग को जानना है रेजोनेटिंग स्ट्रक्चर. सो ओजोन सिंपली दिस वन, calculate this is this one, this O and this O, right? If you will calculate the formal charge, you put here minus and therefore minus. So this is O and this one is 2, 4, 2, 6, this one, and this is O and this one. So this is the resonating structure. So due to this resonating structure, this bond length is another and this bond is length is another. So as a result of the resonance, the bond length, that is 128 picometer, it is found, means equal bond length. Why equal bond length? Due to resonance. Due to resonance. And resonance hybrid is written as this one, and this is O and this is O. Due to resonance, bond length are equal. Bond length equal. Now, what is the use of ozone? Use of ozone, right? This is for your self-study. It is given in your book. That is germicide. It is known as it is as a germicide, disinfectant for sterilizing water, and it will act as a oxidizing agent. For it also act as a bleaching agent for bleaching ivory, silk, wool, etc. These are the application. These are the uses or the application of the ozone. This is all about the ozone. Now we consider the another one is sulfur dioxide. This is very important. Sulfur dioxide. consider another topic, that is sulfur dioxide. This is sulfur dioxide, SO2. This is sulfur dioxide. So, first is the preparation. How sulfur dioxide? There are three equations given in your book. You will write only the three equations. S plus O2. This is preparation. That will give SO2, very simple, sulfur dioxide. Now another, in the laboratory it is prepared by sulfite ion. Sulfite ion. With acid, twice H plus, that is SO2 plus H2O. That should be balanced, plus minus 3 and 2, 3, hydrogen 2. This is second method. And the third one, by roasting of the sulfite O, that is 4, that is FeS2 plus O2 is equal to, right, twice Fe2O3 plus, that is SO2, and this is twice SO2. So Adoni 8 SO2, 8 SO2, right? 8 Adoni 8 Fe2 और Adoni 16 26. So this is by roasting of sulfide ore. So this equation is given complete and valid. So suppose the left part is given and you have to write. It never asked how you will prepare, write the methods of preparation. No, this is simply the application we should know. Okay, how it is prepared, this is enough, the sulfur dioxide. Now, what is the physical properties? Physical properties. Now, this is your part of your self-study, right? You must go through the book. Sulfur dioxide is a colorless, odorless gas, heavier than water. It is collected in the gas jar when you prepare in the laboratory. Is that clear? Now, this sulfur dioxide, how you will show the presence of sulfur dioxide? Now, nature. So, how it is property? This is colorless, odorless, having pungent smell. Pungent smell का meaning है, that is इसको हम लोग तीखा गंध कहते हैं. Right? It is soluble in water. Right? So these are. Now this sulfur dioxide is acidic in nature. Now nature, sulfur dioxide, this is acidic in nature. आपको कहेगा कि आप कैसे प्रेजेंस आप शो करेंगे कि सल्फर डाइऑक्साइड इज एसिडिक इन नेचर, और हाउ यू विल प्रेजेंस द show the presence of SO2 in the nature. So this SO2, this react with water, so it will form H2SO3. इसका नाम है sulfurous acid. This is known as sulfurous acid. So this is the sulfurous acid because it formed the acid, and so it will acidic in nature. If we put the red litmus, then it changes to blue. So this is all about the preparation. This is the property. I narrated this property, although you must go through the book, right? Now sulfur dioxide is acidic in nature. Another way, when sulfur dioxide, this is an AOH, this is the alkali, and you will pass this through SO2, then it will form Na2SO3, and this is H2. 2 to 4, that is 3. Now what will happen? Similar that of the carbon dioxide. When carbon dioxide is passed through lime water, then it will give you a white precipitate of calcium carbonate. Now to that solution, If carbon dioxide again passed in the large amount, then what will happen? This bicarbonate which was insoluble, the carbonate which was insoluble, this carbonate which was insoluble now converted into soluble bicarbonate. Similarly, on passing SO2, excess SO2, SO2, what will happen? This is Na2SO3 plus H2O and plus SO2, that will changes into twice NaHSO3, sodium bisulfite. 3 तो 5 अक्षर, 3 अक्षर, all are balanced. This is called sodium bisulfite. Sulfite, right? This is the properties. It is acidic in nature, and what happens when it is passed through? Because also shows that it's also proves its acidic character, because this NaOH is a base, and if it is a react with that acid, form their salt. This is sodium sulfite. Sodium sulfite. On passing excess of SO2 to that solution, it will changes into the soluble sodium bisulfite. We don't say it sulfate, it is sodium bisulfite. Is it clear? Now, this sulfur dioxide, the chemical reactions, and these chemical reactions are very important. So, now you see the chemical reactions. Chemical reactions. Reactions. What reaction with chlorine? यदि ये क्लोरीन के साथ में रिएक्शन करता है तो क्या होगा? SO2 plus O2. This is very Cl2. Then it is sulfuryl chloride. Simply you add SO2 Cl2. This is called sulfuryl chloride. So this reaction is very important. It is asked complete and balance. Is it clear? Now yes. Now this sulfur dioxide is one of the state to prepare the sulfuric acid. This SO2 gas, now this is O2 in presence of V2O5 as a catalyst, that it will get oxidized to sulfur trioxide. Sulfur trioxide is also acidic in nature because non-metal oxides, right? Now, it will act as this sulfur dioxide. Question है, sulfur dioxide, you calculate the oxidation state of this sulfur here. So this sulfur comes to be in +4 state. Now, the maximum oxidation state of sulfur can go to, this is +6, right? So increase in oxidation number is considered as oxidation. Increase in oxidation number is called oxidation. That means in sulfur dioxide, sulfur is in oxidation state +4, and due to the presence of the d orbital, it can undergo oxidation and go up to the oxidation state 6. So increase in oxidation number का बढ़ना हम ऑक्सीडेशन कहलाते हैं. इसीलिए ये corresponding agent SO2 ये reducing agent की तरह काम करेगा. ये reducing agent. तो आपको क्वेश्चन पूछेगा how SO2 will act as a reducing agent. तो हम लिखेंगे in sulfur dioxide oxidation number is +4. It may undergo the highest oxidation number +6. We know increase in oxidation number is oxidation. That's why sulfur dioxide act as a reducing agent. This is the reason why question why SO2 acts as reducing agent, right? So answer is given here. that is in sulfur dioxide, the oxidation state of sulfur is +4 may go to +6, so it will be oxidation, hence आपके पास लैंग्वेज जैसे भी लिखे, hence SO2 acts as an oxidizing agent. This is reducing agent. Oxidation हुआ तो reducing agent होगा. Now this is one of the explanatory question. Now question is given, what happens when sulfur dioxide is passed? यदि ये reducing agent है तो ये क्या करेगा, फेरिक सल्फेट को फेरस सल्फेट में कन्वर्ट कर देगा, राइट. सो यू सी द रिएक्शन, सपोर्ट ऑफ रिएक्शन इन नेचर ऑफ रिड्यूसिंग एजेंट. नाउ सी this is a reducing agent, so this is Fe3 plus and this is SO2, right. Ferric sulfate like this, ferric sulfate and aqueous solution, this is twice S2, twice, so 3Fe2 plus ferric to reducing agent reduces 2 plus SO4 2 minus plus 4H plus. This is the reaction. So we check the reactions. Twice Fe3 plus, twice Fe2 plus SO4 2 minus plus 2H plus. We check the charge. 6 3 2 6 6 4 10 2 8 2 3 6 and 3 Fe. This is twice Fe. Twice 2 2 4 और 4 8 8 में से 2 गया 6 7. So there is here this sulfur acts as a reducing agent because it reduces this ferric ion. Simply we write here ferric ion. Ferric ion, that is ferric sulfate भी ले सकते हैं and it is ferrous ion. So here oxidation state is +3 and here oxidation state is +2 and here oxidation state plus sulfur is +4. It will get oxidized to +6. So reducing agent reduces other. Reducing agent का काम क्या है, एक दूसरे को reduce करना और क्या हो जाता है, अपने तय वह oxidized हो जाता है. आपको क्वेश्चन पूछेगा what happens when sulfur dioxide is passed through the ferric solution and the salt of ferric ion solution. This is ferric ion and solution, this is a water. Another, this is a chemical reactions in support of, we can write it, support of reducing agent. This is very important characteristics. Now another point, आपके बुक में क्वेश्चन है और पूछा भी गया है कि how you will show the presence of sulfur dioxide. So another property, when it is passed through KMnO4 solution, this is KMnO4 solution. Another 5SO2 plus MnO4 minus plus 5SO2 MnO4 minus plus twice H2O, then it will convert it to, this is Mn, here is +4, here 7, sorry, and it will convert it to Mn2 plus 5 SO4 2 minus and plus 4H plus. Now again it will act as a reducing agent. It reduces, this is a purple color या violet color. Violet और purple दोनों लिख सकते हैं. Violet color, violet, and this is colorless. Colorless, right? So equation balancing check कर लेना आपको. This is twice Mn2 plus, यहाँ हम लोग डाल दें twice, यहाँ भी डाल दें twice. 4 दूनी 8 2 10 10 और 10 20 तो 5 चौके 20। ये बैलेंस आपको चेक करना है, मैं बैलेंस करके देता हूँ। नाउ क्वेश्चन व्हाट हैपेंस व्हेन, अब ये 2 क्वेश्चन पूछेगा कि व्हाट हैपेंस व्हेन SO2 is passed through फेरिक सल्फेट। अब मान लीजिए ये दे दिया ऐसा फेरिक सल्फेट सॉल्यूशन। फेरिक सल्फेट का मतलब है फेरिक सल्फेट सॉल्यूशन, इसका मीनिंग है इट इज हियर Fe3+ आयन। सो क्या हो जाएगा, दिस फेरिक सल्फेट विच इज ब्राउन इन कलर चेंजेस टू फेरस सल्फेट, इट इज ग्रीन इन कलर। नाउ अनदर क्वेश्चन, SO2 is passed through KMnO4 solution, it will decolorize. This is colorless and this is violet in color. So these two properties, and in sulfur dioxide this is the reaction with Cl2, reaction with Fe3+ ion and reaction with KMnO4 minus. Similarly with dichromate ion we can also write it, the reaction, but it is not given in your book, so this is only 3, write this. So what is the uses of this sulfur dioxide and then the structure पूछा गया इसमें, the question is very important. Now uses next I discuss, so I erase it completely. So sulfur dioxide will act as a reducing agent, final our conclusion, and it will reduces and itself it get oxidized. So we have seen the 2 equations, when it is passed through ferric sulfate solution or ferric ion, it will reduce to ferrous ion, and in another, when it is passed through KMnO4 solution, it decolorizes, means its violet color changes to colorless, means MnO4 minus changes to what ion? Mn2+ ion, and ferric ion it changes to ferrous ion, and this SO4 get oxidized to sulfate ion in both the cases, right? So one question, this is the sulfur dioxide, simply आपके बुक में ऐसा स्ट्रक्चर दिया हुआ है, राइट? ये रेजोनेटिंग स्ट्रक्चर बनाना है तो हम ऐसा बनाएंगे, आपकी बुक की बात कर रहा हूँ, राइट? ये ऐसा है, तो कहता है कि इस सल्फर में 2 बॉन्ड है, ये डबल बॉन्ड है, एक सिंगल बॉन्ड है. Similarly, you will try this one, this one. Question is asked, is all the bond length are equal? Answer is very simple, because it is a resonance hybrid, so we can say the bond are equal. ये क्वेश्चन कहता है SO and SOO bonds are equal. Yeah, comment on the bond length of SO and SOO. Write this. So bond SO and bonds are equal. ये क्वेश्चन, तो हम लोग बोलेंगे yes. अब क्यों देंगे? तो आंसर इज वेरी सिंपल, दैट इज रेजोनेंस. So for that, let me to see the time, otherwise much more time will take in 33 minutes. So I will discuss these things in the another lecture, because it will take some time, and H2SO4 is deleted, but you know the oxy acids. Oxy acids के विषय में ऐसा कुछ CBSE ने इंस्ट्रक्शन नहीं दिया है, तो सल्फ्यूरिक एसिड, सल्फ्यूरिक एसिड और वो पर सल्फ्यूरिक एसिड और पर ऑक्सो डाइसल्फ्यूरिक एसिड, इसके स्ट्रक्चर को हमें देख लेना है. तो अभी हम इंड करते हैं. नेक्स्ट लेक्चर में हम इसका डिस्क्रिप्शन देंगे कि ये कैसे होता है. इसका आंसर शॉर्ट में है, रेजोनेंस है, लेकिन इसमें क्या हाइब्रिडाइजेशन होते हैं, 2 बॉन्ड क्यों कौन सा होता है, तो आई विल explain it in a comprehensive way, and that is our motto is to clear the topic or clear your concept. Thank you, and you will see in the another lecture. Thanks a lot.